Here we have the three power reducing formulas: sine, cosine, and tangent, or should I say sine squared, cosine, and tangent squared. They're called power reducing formulas because we're going from a squared power to a 1 power. And sometimes that's useful in solving some equations, simplifying expressions, or whatever. So notice that the only difference between the sine and the cosine formula is the fact that the sine formula has a minus, cosine formula has a plus. The tangent formula, just look at it. It looks like it is the sine squared formula divided by the cosine squared formula. As a matter of fact, if you're going to prove that one, that's what you would do. You just divide the first one by the second one, the sine squared by the cosine squared, after you proved the sine squared and the cosine squared. And so notice that this is pretty easy to prove if we just rearrange the terms in the cosine double angle formulas. So we're going to do that with the cosine squared right here. So as a reminder, double angle formula for cosine of 2u is equal to 2 cosine squared u minus 1. And you can see that this thing looks a lot like that. All we have to do is solve it for cosine squared u. So add over the 1, and I'm going to have way over there, forget about that, 1 plus cosine 2u equals 2 cosine squared u. Now I just have to get rid of my 2 by dividing, and whenever I divide, I will have cosine squared u, just switching sides here, equals 1 plus cosine 2u all over 2. Check. If you were going to prove the one for sine squared u, you do exactly the same thing, except for the formula for sine, the cosine 2u is 1 minus 2 sine squared u. And you just rearrange those terms to make it look like that. Pretty easy. And then again, lastly, if you're going to prove the tangent one, just divide this first formula by the second formula. The 2's would cancel out and you'd be done.